Okay, I have this page. First page, okay, first page basically put out everything. This is what you need to learn for year 12 methods. Okay, everything is there. So basically we talk about chain rule, product rule, and quotient rule. We have, if you look at this table, like if you separate it in the middle, the right hand side is a more complex way of the rule. I will recommend, if you want to memorize the rules, memorize the right hand side. I know a lot of you will memorize the left hand side, then using the chain rule to do it. I think it's a little bit slow, and when you go anti-diff, when you go backwards, it's not that helpful. Okay, so when you think about chain rule and the basic rule together, it's not that helpful. So I will recommend you to remember the right hand side. Okay, the right hand side. So for example, if you talk about I want to diff e to the power of gx, okay, e to the power of gx. So it's the diff of g dash x, and then repeat the function again, e to the power of gx. All the functions, if it's a composite function, all the functions you will have one element, which is g dash x. You can see everything got g dash x. You need to just diff the inside function anyway. Okay, you need to differentiate inside function anyway. So we have g dash x to all of it. And if you think about x to the power of n is n to the power of x n minus 1. I have one wants to talk about with you. This is something students always forget, like they know how to do but always forget. What's the differentiation for that? What's the diff for that? N times, yep, to the power of n minus 1 and times by what? A. You want times by x, okay? You never times x is the variable. You times by the coefficients. So I can put the a in the front. A and ax plus b to the power of n minus 1. What? I know, like, if you haven't learned method, I know it's really hard, but there's no other choice. You just need to remember it. That's like what we can do. So, well, at least it's not the set yet. You just need to remember it. It's very harsh, but like that's the way how we can do it. So that's for differentiation. We can always remember the a, but when we do anti-differentiation for that, we always forget to divide by the a. That's something I want to remind you. Remember there's a there. Well, you can times it at the back. Doesn't matter where we times it. I move it to the front. Yeah, I put it on the end and then I wrap it off and then put it in the front. Okay. One thing really important is the log one, because later when we do anti-diff, we use the log for the log rules. So it's the g dash x over gx. Whatever in the log function. This is the only one looks not the same as before. Think about exponential still have exponential. Circular functions still get into a circular function. And polynomial still looks like polynomial, but log is the only one no longer have log in it. So when we differ is the g dash x over gx, we no longer have the log. Okay, so g also about the chain rule. So gx to the power of n, that's how we do the top question. It says n times g dash x at gx to the power of n minus 1. So that's the basic rule we learn in methods. Okay, so there are how many? Log, exponential, sine, cosine, and tangent? 5. Okay, so sine go to cos go to minus sine, and tangent go to sec squared. Okay, tangent go to sec squared. Like, okay, so now I will assume everyone know this rule. Or if you can't remember, just look at the rule. And we talk about chain rule. Well, chain rule is basically, this one is really important. Okay, so this one is very important. You need to remember that all of these rules actually coming from, like all of the rule I give on the top is actually using this chain rule here. So f of gx, chain rule is to talk about the differentiation for composite function. Okay, f of gx. So we diff the inner function first, and then we diff the outer function, and then we still have the inner function in the differentiation of f. So it's g dash x times f dash of gx. Okay, so this one is very important. And product rule and quotient rule is helping us to do differentiation when we have functions times together or functions divide each other. So u times v is u v dash plus u dash v. So we diff one, keep one as original, and we swap the dash, we plus the result. Product rule is easy. Okay, product rule is easy compared to quotient rule. Okay, quotient rule is v divided by u divided by v. So how I remember this one is, first thing is we need to square the bottom. It is not actually true, okay? That's how I memorize it. So I always remember, okay, I need to square the bottom. So when you times something on fraction, what do you need to do on the top as well? You need to times the same thing, right? So I times the v on the bottom, I'll times the v on top as well. So the next thing followed by the v will be a u dash, because you know like u and v dash, v and u dash will combine together. So if you already have a v, you need a u dash. And then it's a minus sign. So you swap the dash, like it's the v dash times u. So that's the rule. Basically, that's how I remember it. I don't need to go to formula sheet every time to think about it. So if I square the bottom, I times a v on it. So I'll times a v on top as well. So then that v needs to combine with a u dash, and then minus when you swap the dash place. Again, nothing really needs to teach here because it's just formulas. You just need to remember them. Let's look at example one. I will assume you know the rule. Okay, so let's think about example one. I want to differentiate this function here. What's the quickest way to differentiate that? So what I combine? Well, let's think about that. What's log gx? What's the differentiation of log gx? G dash x over gx. Do you want to make the bracket becomes really complex? That's my question. Do you want to make a really complex expression and then over that really complex expression? Rather than combine them, what do you want to do? Separate them. How do you separate? How do you separate? What's the square root? What's the power form of a square root? Half. What did I do in the half? Take it out. That's it. That is good enough. It's a linear inside. It's good enough. And how about the log e 4 over x squared minus 1? What kind of rule I can apply to that one? Something divided by something in log. Minus. Okay, remember the bracket outside because you will change the plus later. So what's the f dash x equals to? First one, like the half will stay here, and g dash x of 3x minus 2, what's that? 3 on 3x minus 2. How about the diff of log e4? 0. 0, yeah, plus. What's the diff of the last term? Again? Thank you. Good. We should encourage him. That's good. Well, at least I have some reactions from students. That's good. All right. Let's go to the next page. Well, the next one is a practice. You'll do this practice later, and I'll show you the solutions later. But let's have a look at this one. Next page is something fantastic. You just learn sec, cosec, and cot, right? You just learn those three. So this is the differentiation for those three. The good news is you don't need to remember those ones. Okay? So what I would recommend you to do is you put this on your bond reference. It's not going to be on the formula sheet. So you put this on your bond reference. When you see that in part 2 exam, you can look at this. In part, well, if it appears in part 1 exam, what you should do is you just should leave this by yourself. When we do the anti-diff question, there are some particular form I need from this page. So it's a useful page, okay? It's a useful page, but you don't need to remember it. If you can remember it, that would be really great. But if not, make sure you put that on your bond reference. I will show you one of them, how to get the differentiation. So sec. So what's sec? 1 on cos. So I can say that's cos x to the power of -1. Well, I'm not going to put the -1 in between cos and x. That's the inverse. So I want to d dx of that. So which means I want to differentiate that. So to differentiate that, I need to use the chain rule. So I will have this -1 here. And I will have cosine x to the power of -2. Okay, I will reduce the power by 1. And I need to times the diff of the inner function. So what's the diff of cos? Negative sign. So what that equals to is just a positive sine x over cos x. Well, it's squared, so I will times another cos x here because I want to make it into that form. So that's a 10x, that's a sec x. Okay, so when I want to diff this one, we will have 10x times sec x. So that's why we have 10gx, sec gx, and g dash x. Okay, so it's just another use of chain rule here. You can prove the cosec and cot 1 by the same idea to the power of -1, but well, you need to know how to diff that, but you don't need to remember the result. That I will suggest. That will be what I suggest. You have 3 exercises to talk about the logs diff for ABC, and there's one more question on part B here to use of the quotient rule. Okay, to use quotient rule. If you're quite confident about that, you can just start doing textbook exercise or like the VCAL questions. If you're not that confident, maybe try to do the quotient rule and try to complete the following 3 there, the sec, cosec, and cot 1. Nothing really I need to talk about a lot today, but I think before the next class, you can remember all these rules or at least know how to do the rules when you look at the formula sheet. Okay, so it's really important. If you don't know the rule, there's no way I can keep going for the later on exercise. Okay, so either try the 4 exercise or you can start doing some textbook questions. Which one? This one? You don't really need to put it onto one fraction. If you want, you can make a common denominator and do it, but I don't really require simplifications in this case.